All right, so this is question 13. A little chunkier than the last couple, but it's all right. We do have two classes, so let's go look for anything that could instantly resort in an error, right? So let's go look at this class, right? Class test. That is a public but static field. All right, interesting. We do have a default constructor, or I guess not a default constructor, but a constructor that takes in nothing, right? So if we ever see like tests, or I guess like new tests of one, that would be an instant error, right? Because that is the only constructor that we have. It's not overloaded, which means that if you try to do that, like sort of like test anything besides nothing, so like anything besides like something that's empty, it's not going to know where to go, and it's going to crash, right? But if we have like new, or actually if we had something like this, that's totally fine because it knows where to go. It's going to go right there, right? So the constructor is probably not an issue. And it also looks like we have an overridden toString, right? And I'll talk about this in a bit here. But other than that, looks like nothing in here is going to cause a crash, or at least nothing obvious, right? So what we'll do is we'll start a main, and we'll just go line by line, right? Right. So starting at the first line here, it just looks like we're declaring a new test object, right? So I'll say that T1 points to um, a new test object. And let's go look at what the constructor is going to have us do. It's just going to say data minus minus, right? And you might think that's bad because, we don't explicitly call this equal to 0, but Java will have already set this equal to 0, right? Just like when you declared it. So we're not going to run into that issue. It'll be 0, I believe during compile time, right? It'll have been initialized, and then we just do data minus minus. Now here's the thing, right? It's static, which means that every single, I guess, test object should share the same value for data. So here's what we'll do. I'm going to put like data over here. Data is equal to something, right? So off the, I guess, like off the rip, right? At the very start, data is equal to 0, and then we created this new test. So we had to go to the constructor, and what does the constructor say? It says I need to decrement data by 1. So that's exactly what I'll do, right? I'll just go over here and say 0 minus 1 is negative 1. And that's what every, I guess, test object has. So every single test object has data that's equal to negative 1, right? So when this data changes, it changes for every single object of test type, right? So then with that in mind, when I go down here, and I also recognize that this is public, so this is totally cool, right? So t1.data is equal to 6. It's saying that I need to go access T1's data, which is over here because it's static, and set it equal to 6. Right? So now every single test object has data equal to 6, not just T1, but any single, or I guess any object that is of type test has data equal to 6. All right. So now what we're going to do is we'll just go to the next line, right? I make another object of type test. So T2 points to another object, right? And what does it do when we throw it into the constructor? It just does data minus minus, right? So where's data? Data's over here because it's static. So I'm gonna say that 6 minus 1 is 5, right? We just decrement it by 1. So because this is an object of type test, it points to the same, I guess, like memory location for data, meaning that it's going to share the same value, right? It'll share the same value as T1 or any other test object, right? So what am I going to do? I'm going to go to the next line. Now it says system out print line T1, right? And T1 is an object. Well, what we do when we're just printing out an object and not something like T1.data, no. That's not what we're doing. We're just printing out T1. Here's the thing, right? Forget about this for a second, right? Every single class has a, I guess, sort of like built-in method that was inherited called toString, right? Takes no parameters, returns a string, I believe, yeah. Um, and what it would do if we had just if we hadn't overrid this, so like pretend this doesn't exist. When you print just an object, toString is called the default toString that's created by Java, right? It's called, and what it does is it is sort of prints out what type the object is. So in this case, it would be test. So T1 is a test object. And where is it located? Some hexadecimal address, right? So it would be what type is the object and where is it located? That is what the default Java toString will do. That's what you'll get had this not existed. But since you, the programmer, overrid it, as seen here, right? We overrid the toString method, so now we're going to get it to do what we want. This is what Java would have had us do, but now we're gonna make it do something different. We overrid it, right? The difference between overriding and overloading is overloading would have had you have different parameters here. Overriding is saying I'm taking this default method or this method that already exists and I'm changing it up to do what I want it to do, right? So they overrid it. So instead of calling Java's toString, I'm calling this. Wow, I'm calling this, right? So we're at the toString. We just need to see if data is equal to 6. Clearly, it's not, right? It got shifted around a little bit, but this is data, right? So data is not equal to 6. So what do I have to do? I have to return B, right? So system.out print line B, right? So we would just print out B, and don't get tricked by this, right? Your answer was B. Don't like accidentally circle B. Like I think that's probably happened to me before. I've been very mad at that. Like just make sure to like look at your answer choices very 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 carefully. Our answer was B, and we had to circle C. So don't get tricked up on that on the test, and kind of give this answer some attention for a bit. Um, this is what toString might have printed had we not overrid it. Like don't really worry about the A, worry about this, right? So what is T1? It's a test object. Where is it located? This hexadecimal memory address, right? That's what toString would have printed out or could have printed out depending on the memory location, had we not overrid it. But we did. We had toString do what we wanted to, and it instead printed out a B. Just because the data was not equal to 6, it was equal to 5. So we circle in C, and we go verify our answer. The answer is in fact C for question 13. Yep. I will see you in the next one.